Okay, here is another section in probability chapter. We discuss about complements and conditional probability. We talk about the concept of at least one probability of finding at least one situation, and we use a conditional probability here. And to find out the probability of at least one situation, we need to use complements. So when finding the probability of some events occurring at least one, we should understand the following. At least one has the same meaning as one or more. The complement of getting at least one particular event is that you get no occurrence of that event. The complement of getting at least one particular event is that you get no occurrence of that event. So these are the notation. Let A, that means getting at least one of the some events, and A complement is getting none of the event being considered. Then there is a relation. Probability of finding at least one occurrence of event A is equal to 1 minus probability of finding no occurrence of event A. Okay. To understand this, let's assume that we have a coin and there are two faces of the coin, head and tail, and we do the flipping two times, two flips. Okay, so when we do the two flips, these are the our sample space. uh, it could be head and head both time, it could be head and tail, it could be tail and head, or it could be tail and tail. So there are four different situations when we flip a coin two times. So now if we want to find out what is the probability of at least one head, which can be found just by looking the sample space here. It has one head, it has one head, it has one head, then we already know the answer. It's the probability of finding one head is 3 out of 4. But we can also find this thing by using this complement formula, which is probability of finding at least one head is equal to 1 minus probability of finding no head. And this might be useful formula because we know the probability of finding no head is there is only one situation. So out of 4 there is only one situation where is no head. So you just have to subtract 1/4 by from 1, which is eventually 3/4. So sometimes we cannot visualize our sample space, uh, and we use this formula for finding at least one case. Okay. Okay, let's look at let me see. Yeah, conditional probability. So let me just go over some example here. How many we can do. Let A, the event of getting at least one defective calculator when 4 are randomly selected with a replacement from a batch. Write a statement describing event A complement. So A means the event of getting at least one defective. So complement of A is, complement of at least one defective is all of them are defective. Okay. The event of getting no defective among the 4 calculator. The event of getting at least one defective. At least one defective mean it could be one defective, it could be two defective, it could be three defective, it could be four defective. All 4 of them could be defective. So the complement of the that event is no defective. So the event of getting no defective among the 4 calculator, that's the complement of A. Okay. So let's go to another problem. Okay, so to understand this, we have to talk about this conditional first. So and here the next topic is conditional probability. Conditional probability of an event is a probability obtained with the additional information that some other event has already occurred. So for example, you want to find out probability of event A given that the event B has already happened. This is the notation we use for conditional probability. So the probability of event B given that event A already happened. Okay. So the conditional probability of B occurring given that A has occurred can be found by assuming that event A has occurred and then calculating the probability that event B will occur. So that is the intuition, and to find out that, we can use this formal way or formula. What is the probability of finding the B given that A has already happened? Can be found by finding the probability of A and B, which is a multiplication rule, and divided by probability of A. Make sure that probability of A is non-zero. If it's zero, then we cannot use this formula. One thing keep in mind, probability of B when given A and probability of A when given B, they are not same thing. They might be they might give you the different answer. They are not same. Okay, to understand that thing, let's say one example. Let's see one example. Let's say D stands for it is dark outdoor. M stands for it is midnight. So now we can say that probability of finding the dark outside given that it's midnight is 1, because so when it's midnight it's already dark, so the chance is 1. It's for sure, it's certain. But probability of this midnight, it is midnight given that it's dark, is very, very low. At only one time, specific time, it's in the dark, it's a midnight, so the chances is very low. That's why the probability is 0. If the chances is very, very, very low, practically we can say it's a 0. The probability that it is exactly midnight given that it is dark is almost 0. It's not 0, but it's almost 0. So here we can see that these two conditional probability might not be equal. So don't be confused. Confusion of the inverse occurs when we incorrectly switch those probability values or think that they are equal. Okay, there is one theorem. It also helps us to calculate this thing. Probability of A given B can be calculated by using this formula as well. Probability of B given A times probability of A and divided by probability of B, provided that probability B is non-zero. This is called Bayes' theorem. Okay, prior and posterior probability. Prior probability means a probability. Prior probability is an initial probability value originally obtained before any additional information is obtained. And posterior probability is a probability value that has been revised by using additional information that is later obtained. So these are the things we should know from this section. Now I'm going to show you some examples by using this formula and then concept we just discussed here, conditional probability, and let's see some examples. So let's see. Okay, this is second one. Let event A equals subject is telling the truth and event B is equal polygraph test indicates that the subject is lying. Use your own words to translate the notation probability of B given that A. So remember, B means polygraph test indicates the subject is lying given that subject is telling the truth. So that's what we are going to find out. The probability that the polygraph indicates B is lying, so it's not truthfulness. So the answer could be C or D. So let's read C. The probability that the polygraph indicates lying given that subject is actually telling the truth, and that is right, because probability of happening event B, which is polygraph test, indicates that the subject is lying given that actually subject is telling the truth. Okay, let's see another example here. Based on a poll, 62% of internet users are more careful about personal information when using a public Wi-Fi hotspot. What is the probability that among 4 randomly selected internet users, at least one is more careful about personal information when using a public Wi-Fi hotspot? how is the result affected by the additional information that the survey subjects volunteer to respond? So if you go back to our at least you know here is the thing. For finding the probability of at least one occurrence of an event, we can use its complement, 1 minus probability of no occurrence of that such kind of event. So in our case, there are four Wi-Fi user we are taking, and out of four, what is the probability that among four randomly selected internet user, at least one is more careful? So remember, based on a poll, 62% of the internet user are more careful, right? So that means 62% are careful, right? And then that means out of 100, 62 careful, so the remainder is 38%. 38% are no careful, they are not careful. So we would like to find out what is the probability if we choose 4 internet user. Look at here, what is the probability that among 4 randomly selected internet user, at least one is more careful? So at least one is more careful, at least one is more careful, which is same as 1 minus probability of no one careful. Out of 4, we know that 38% chance is not careful. So we have to calculate what is the probability of finding out of 4 no one is careful. So remember, probability of no one is careful out of 4 is actually 38% for the first person, 38% for the second person, 38% for the third person, and they are independent events. So we just have to multiply all these 38.38 4 times, okay, and then which is actually 0.38 to the power 4, and we have to subtract this from 1 to find out probability at least one is more careful. So I'm going to use a calculator from here. 1 minus inside the parenthesis 0.38 to the power 4. So it's a complement of no one is careful. So the answer is 0.9791. So let's go back to the problem here. They want us to write down in 3 decimal place. So 3 decimal place, it's a 0.979. 0.979. Excellent. Okay, so how is the result affected by the additional information that the survey subjects volunteer to respond? If it's a volunteer, then it could be a different thing. So let's read the option given here. The results should not be impacted by this because there is no reason to lie when responding. The results should not be impacted by this because volunteers are likely to have the most relevant response. It is very possible that the result is not valid because not everyone uses public Wi-Fi. Finally, it is very possible that the result is not valid because the sample may not be representative of the people who use public Wi-Fi. So this looks more accurate. The fourth one, whenever you ask for volunteer, then the volunteer sample does not represent, might not represent the actual sample of the population. Let's see next problem here. Assume that there is a 9% rate of disk drive failure in a year. If all your computer data is stored on a dark hard disk drive with a copy stored on a second hard disk drive, what is the probability that during a year you can avoid catastrophic with at least one working drive? So in this case, we are going to use the same idea. What is the probability of at least one hard disk is working? So probability of at least one hard disk is working. Probability of at least one hard disk is working, and this can be found by subtracting probability of no hard disk is working. I mean we are using the two hard disks, no, and both of them are not working, so probability of both not working, we have to subtract this probability from 1. So if you have two hard disks, hard disk 1 and hard disk 2, we know that the probability of this first hard disk not working is 0.09 because it's a 9% failure rate, and probability of hard disk 2 not working is again 0.09. And because both those two hard disks are independent of each other, so probability of both not working is equal to probability of first one not working H1 times the probability of not working S2. So you just have to multiply this 2, which is 0.09 whole square, and you have to subtract that from 1 for finding at least one is working. So the answer is, we can use this thing, the answer is 1 minus inside the parenthesis 0.09 to the power 2. 0.09, so I use 0.9, so that's a mistake. Okay, 1 minus inside the parenthesis 0.09 and then power square. So this is the probability of at least one hard disk is working, 0.9919. So the probability that at least one hard disk is working is 0.9919. With the 3 hard disk drives, the probability that catastrophe can be avoided is, remember, now we can just extend this formula for any number of hard disks, because it was 2 hard disks before, so we use the square here. For 3 hard disks we have to do the same thing, but now it's a 0.09 to the power 3. It's just power, you just have to increase the power. So using that fact, if I go back here and then subtract that 0.09 to the power 3 from 1, it gives me 0.9993. If you have to, depending on what they are asking us, 6 decimal place, so 999271, 0.999271, 6 decimal place. Okay. Okay, so let's go to another one. Okay, these are the some definition we cover in this section. Confusion of the inverse occurs when we incorrectly believe that these two are equal. Let's go to the next one. Complete the following statement. The conditional probability of B given A can be found by assuming the event B has occurred and then calculating the probability that event A will occur. Assuming that event A has occurred, yeah, this is right, and calculating the probability that event B will occur. That's coming from the definition. Okay,